Long before smartphones, before computers, before electricity, humans built a machine that changed the way we think forever. A device that could add, subtract, and eventually calculate faster than any human alive. This is the story of the first calculator and how it worked. Before machines, humans used their environment as their calculator. Stones for numbers, knots on ropes for records, and eventually the abacus. Invented thousands of years ago in ancient Mesopotamia and refined by the Chinese, the abacus was the first real calculating device. How it worked was simple. Each bead represented a number. Sliding beads, left or right, added or subtracted value. Columns represented units, tens, hundreds, and so on. This was humanity's first step toward mechanical math. But it wasn't yet a machine. By the 17th century, the world grew more complex. Businesses needed accounting. Governments needed taxes calculated. Human error was slowing everything down. And then, a teenager changed history. Blaise Pascal, at just 19 years old, built the world's first working mechanical calculator, the Pascaline. How the Pascaline worked, Pascal's machine was built with gears, wheels, rotating drums, and a brilliant mechanism called the carryover system. Here's how a calculation worked. 1. You inserted a stylus into a numbered wheel on the device. 2. You rotated the wheel to add a number. 3. Inside, teeth on gears turned connected wheels. 4. When one wheel passed 9 and turned to 0, 5. It automatically carried 1 to the next wheel. Just like today as calculators roll over from 9 to 10, the Pascaline did the same mechanically. It was the first time in history a machine did math by itself. But Pascal's machine had limits. It could add and subtract, nothing more. Then came another genius, Gottfried Wilhelm Leibniz. He built something even more advanced, the step reckoner. This device introduced a new technology, the step drum. How the step drum worked. Imagine a rotating drum with teeth of different heights. When the drum turned, a long tooth moved the gear many steps. A shorter tooth moved it fewer steps. This allowed the machine to add, subtract, multiply, divide. For the first time in history, a machine could perform complex arithmetic.